children. This is Mr. Moorhead coming to you from the Cleveland campus of Moorhead Studios. We're going to get a lesson today. I'm going to try to go kind of quick on this. I think the other videos have been a little bit longer than they needed to be, but just listen up and a lot of interesting stuff that you can learn. If we go back in history, especially to the 17 or 1800s, actually before then, when people got out into the ocean, they had tons and tons of problems. And it's not just one, it's every single person that goes into the ocean. So I want you to listen to these stories and see if you can figure out what problem they have. First one we're going to start with are the Pilgrims. A lot of people don't realize we associate the Pilgrims with Massachusetts, which is up here. But the Pilgrims are actually trying to go to Virginia. They ended up landing here by accident. Look how far away that is. If we're driving that by a car, that's a little over 10 hours. And you can see that's a huge miss. That's as big a miss as you're trying to go to Virginia and you end up at the tip of Florida. That's a pretty large miss. Again, Pilgrims landed here. They just stayed there. So let's try our next story. This one is about the Mongol Empire. The Mongol Empire conquered almost all of Asia, but they did not conquer Japan. So they tried to take it over. They're going to launch from Korea, and they just have to go right here. All right. It's not that big a trip. They actually ended up all over the place. They ended up here. They ended up down here. They ended up at other islands that they didn't attempt to go to. Like, it was a huge debacle. Not only did they do this once, they did it twice. They were consistently getting lost, even though it was this tiny, tiny trip. Our final story, the Normans. The Normans are from modern day France. That's right here. They attempted to invade England in 1066. Have a pretty short trip, about 70 miles that they are trying to go. They missed their target by 122 miles. So again, they only had to travel 70, but the spot that they were supposed to land on, they missed it by 122 miles. If you don't understand that, that would be like trying to go to Smithfield and you ended up in Greensboro. So that's a significant, significant miss, even though they had the shortest trip of all the people listed. What these stories have in common is that when you got into the ocean, you always got lost. Christopher Columbus, Magellan, all the famous explorers, they all got lost. Not once, but every single time they got into the ocean. What all three of those stories have in common is those people are traveling in some form or fashion east-west. Medieval people, even ancient people, could always tell north and south because there's the North Star. They could measure themselves how far north they are by using that star. They could measure themselves south by also using that star. How far have they gotten away from the star? But when you go east-west, there's no star to line up to. And unlike being on the land, there's nothing to line yourself up to. There's no direction in the ocean that's like turn right at the stoplight or turn left at the super Walmarts. Like, it doesn't exist. The ocean looks the same no matter where you are. So these people would consistently get lost. Even up until about the 1800s, if you were in a boat, and they have a little bit more technology by then, if you're in a boat and you're only lost by 3 or 4 miles, that was considered pretty awesome. Like, you did a really, really good job. So when you get out into the ocean, you get lost. Why? Why does that happen? Except for when you're going north and south, you can kind of figure that out. At any rate, there's going to be a contest. There's going to be a massive accident off the coast of Ireland. So over here, there is a rocky island. And when people are returning from across the ocean, they get lost. They can't tell exactly where they are. They constantly kept hitting this island on their way back to Great Britain. Finally, there's a nasty accident. It rips the bottom out of a boat. You're going to have hundreds of people dead. Not to be morbid, but there's so many dead from this that when people go to the beach in Ireland, like, there's dead people laying on the beach for the next couple of months. People would just wash ashore from this accident. Finally, the government of Great Britain, okay, that's the modern day UK, said, we need to do something about constantly getting lost in the ocean. We need to do something about not being able to find our way. We need to be able to pinpoint exactly where we are. So they have a contest. They offer the equivalent of several $1 million for anybody that can figure out exactly how to tell where you are in the ocean. So The smartest people from around the world entered into this contest. Nobody could figure it out. Had scientists, they had various other categories of scientists. You would have astronomers, you would have physicists, you had geographers, there's cartographers, people that make maps. It's like some of the smartest people on the planet, they can't figure it out. Quite some time goes by in this contest, still haven't figured out the problem. And a guy comes in and says he thinks he figured out how to solve this problem. So folks are like, who are you? Which famous scientist are you? And he's actually a clockmaker. He has a clock shop in England, and he says he's figured it out. He's invented a clock that will measure where you are when you go east-west. You combine that with north-south, you will know exactly where you are. And people didn't believe him. That would be the equivalent of like me. I'm a social studies teacher finding the cure to cancer. Like, that's not what I do. That's not anything associated with my job. But anyway, they're going to go ahead and test this. They take his clock, they learn how to use it, they send a boat out into the middle of the ocean, they bring the boat back at the exact point it left. It was not lost at all. This is tried multiple times, and each time they did not get lost. He figured it out. Now he goes to claim the prize. This is John Harrison. He's going to get millions of dollars, wealth beyond imagination. And the government of Great Britain actually refused to pay him. They called him a cheater. They said there's no way an ordinary person who makes clocks could figure this out. People ran articles in newspapers. His reputation was damaged, and he actually sued the entire country of Great Britain. He won in court. He proved that he did invent the way to figure out this massive problem that existed for hundreds of years. Again, his name is John Harrison. He's not famous because for the majority of his life, he was called a liar. But at any rate, you can go to his clock shop. It's still there. It's a museum. It's near Greenwich, England. You can see all of his tools that he came up with. But this should be a guy that's mentioned with like Galileo or Aristotle. Like, he solved a massive problem. But because of this weird contest and folks saying he cheated for most of his life and him finally proving that he didn't, he's just not that famous. So kind of a sad story there, but he gives us something. He gives us longitude. This is something we could not measure. Latitude means north-south. We could measure that with a star. Longitude is east-west. We couldn't measure that. His clock does so, and it's based on time. That can get very complicated. I don't want to get complicated here, but he measures how far over you are by seconds. So when you combine the two together, longitude and latitude, it's virtually impossible to get lost. So we're going to look at this just a little bit. This is John Harrison here. You see him? You can see his clock. All right. You can see these other clocks that he has built. But again, he is going to use a clock to solve this problem. Now, latitude, it is going to go across on a globe. So it goes this way. You see my mouse, which way I'm going? That's which way latitude goes. Even though it goes across, it measures up and down. I want you to think of a ladder. This goes across. If you're just walking sideways in the room, you don't need a ladder. But if you're going up and down, you step on the across part. So if this was latitude, and this is 0 degrees, 20 degrees, 40 degrees, 60 degrees, 80 degrees. Latitude, even though these lines go across on a globe, you use them like a ladder. You climb up them. So again, latitude, this is the one we've always known because of stars. It's longitude that we didn't know. So again, let's take a look at this. This line goes across on a globe, but it doesn't measure across. It measures up and down. Here's the equator. You can see it there. It measures going up. So 20 degrees north means you're 20 degrees north of this line. 20 degrees south means you're 20 degrees south of this line. So again, you use it like a ladder. I climb up. If you're going up in the air, you would step on the ladder. All right, so remember, latitude and ladder. They sound similar. They work the same. They teach you to go up or they teach you to go down. This is the one that we couldn't figure out. It's longitude. It's east-west. There's nothing to measure it, but thanks to John Harrison, we now can measure it. This one works like a football field. So if you are watching football, and even if you close your eyes and the announcer says the running back has the ball, he goes to the 50, the 40, the 30, the 20, the 10, touchdown. Like, I don't know if that guy is down here. I don't know if he's up here, but I can tell these lines, he's using them to move across. Okay, that's how the announcer calls it out. So this line that runs up and down, when you get a whole bunch of them together, it tells you how to go across. Okay, so longitude, it works like a football field. I think of the O in longitude, it's the second letter, the O in football. Okay, now when you combine the two together, oh, I'm sorry, I got ahead of myself. Let's go here. So on a real globe, the prime meridian is here. That goes to the center of the planet. That is the line that John Harrison, that's where he marks it. He kind of marks it right through where he lives too. So if it's 20 degrees east, that means you're east of this line, just like the football field. If this is the 50-yard line and I say 40, you moved over 10 yards. All right. So for the prime meridian, 20 degrees east means you're east of this line. 20 degrees west means you're west of this line. The next line that you see on a globe is 40. The next line that you see would be 60. So that is how it goes. It tells us east and west. Now, when we combine these two lines together, you see how it creates a grid. Now, you might think to yourself, well, that's a pretty big grid, but there's lines in between this, okay? You can generally take your phone. I have an iPhone here. Please don't pull that out in class, but hopefully you can see this. So you see I'm using my compass. If I get it to use my own direction, which there's a feature on there, not quite sure why it didn't pop up, but it will tell you your latitude and longitude. And you will see that there's actually like a 31 degrees. There's a 31.2278. So there's a bunch of little tiny lines in between the big lines. We just don't put them on a globe because then you wouldn't see anything. It would cover the whole place. So let's walk through here and take a look. I have a 45-degree line right here. This is latitude. It goes across, and I use it like a ladder. If I am telling north, all right, if I'm trying to figure out how far north I would go, again, I'm using the equator as my base, 15 degrees. That means I'm 15 degrees above the equator, so that's 15 north. It's just like a ladder. If I go to 30, here's the 30, goes across, use it just like a ladder. All right, I need to go farther north, 45 degrees. You can see it's used just like a ladder. So here's latitude. It's listed over here on the side. And again, it works like a ladder. This is the one that John Harrison figures out how to measure. It's longitude. It's this one. So here's 0 degrees. All right. And this 15 means that I'm east of this 0 line. This 45 means that I am east, 45 degrees east of this line. And when I combine the two, again, it creates a grid. So let's watch. If I say that I am 30 degrees north and 105 degrees west, I am right here at the border of Mexico and the United States. This is how these people did not get lost. They would take that clock, they could pinpoint their exact location, and then adjust and get exactly where they're supposed to be. So if this confused you a little bit, we'll do some more tomorrow. But remember, latitude is the one we could always tell based on stars. Longitude, that's the one we could never measure. And this major problem was solved by John Harrison. The guy should be super famous. He won the contest. He ended up having to sue. I don't think I mentioned it, but he did get some of the money, not all of it, but he got some of it. But again, this guy was called a liar in the news. People damaged his reputation, but he solved the biggest problem. He created a way to measure a grid, and we still use it today. If you get lost, if you're trying to build a house, people measure the longitude and latitude of the house. Construction, pilots, any type of navigator, they all use longitude and latitude. So it's super important even to this day. All right, guys. So I hope you enjoyed how latitude and longitude comes about. We're going to take the notes. After you have finished taking the notes, you're going to play some of those review games that I have posted. And tomorrow, you're going to actually get practice on how you do latitude and longitude, and I will have you find places when I give you the 2 coordinates. Thank you guys so much for listening, and bye for now.